let's go ahead and get started then. All right, so I guess I'm going to be looking at my slides, Greg. So if there are questions in the chat, if you want to kind of moderate a little bit and stop me, we can answer them as we go. If not, I'll probably stop every once in a while and check the chat as well. But if anybody has any questions, feel free to put them in the chat. Or, well, I guess I don't know if you can speak up directly or not. But all right, let's go ahead and get started. So first of all, everybody, thank you for joining us. My name is Aaron Pena. I'm the productization lead in R&D for basically our package management products. That includes, NI Package Manager, as well as just general packaging and installer technologies. And with me today, we'll be also presenting some content will be Greg McCaskill, who's a chief engineer on the LabVIEW team. So what are we going to talk about today? At a high level, we'll be talking about packages and the work that we've done thus far around forward compatibility and project scoped add-on management. We'll do a little bit of traversing back on how we got here, what kind of has led us to where we are today, the plan and the solution that we're pursuing. We'll talk about that. Greg will talk a little bit about how the impact that this may or may not have to LabVIEW, our LabVIEW 20XX product. And then if time allows, I can do a quick little demo of kind of where we are with regards to actually seeing it in product. So that's, again, I don't know exactly how long this will take, but we'll get started and see where we end up. So a little bit of the background. So as I mentioned, I'm the productization lead for package management. I came into this role specifically kind of towards the end of 2017, beginning of 2018. And pretty much immediately, kind of the first big event where I was able to get together with a lot of customers was NI 2018 in May. And one of the things that I saw there was this presentation, a presentation called Community Sharing Ideas, kind of being led by Chris Cellino, and then Derek Trepanier was there, who did kind of I think was an impromptu demonstration of a tool that he had been working on called GPM, which has since evolved into being a package management tool used in LabVIEW. I thought this was particularly interesting, especially because it applied to my area and was, kind of my first introduction into this desire to have these project scoped add-on management tools. In addition to this, obviously, we have this thing called the Package Management Idea Exchange, where Chris Cellino again is very active, and he put up a couple of different ideas. One around being able to install packages to multiple versions, or an idea of forward compatibility, and these per project virtual environments. So these two things that as you can see, have 49 and 39 kudos respectively. These are, I think, number 1 and number 3 of our top kudoed ideas in the Idea Exchange. So we knew that we had to do something, right? This is something that was obviously important to the community, important to our LabVIEW base. So we wanted to make sure that we did something to figure out what to do here. So what we did was, over the kind of ensuing 18-ish months between NI Week 2018 and the fall of 2019, was obviously collaborate with a lot of our passionate customers, inclusive, of different events like the CLA Summit, and NI Week, as well as the numerous, customer calls and visits, which, again, a big thanks to all those people who let us kind of interview and bug them and run ideas by them, like the people like Chris and Derek, but other folks as well. I don't want to start naming names because then I'll forget some people, but big thank you. The other thing that kind of came up over this time was the introduction of G Central, which is a nonprofit organization that is, trying to and kind of raise the LabVIEW community up. And so they've been a big help and a big contributor to a lot of these ideas. So thank you to them as well. But ultimately, what this led us to was something that we refer to as concept testing. So this was a big effort that we as an R&D group, specifically my teams, my squads, did kind of in the fall of 2019, that consisted of 10 customer interviews. Again, I won't call them out by name, but thanks again. And all these interviews were about an hour long, where we showed them, 4 high-level abstract concepts that were not super specific, but tried to tease out different priorities and requirements from these people that we were interviewing, asking them, kind of starting with what is their current solution to doing these sorts of per project isolation and forward compatibility, asking them, would these particular situations work for you? what doesn't work for you in these situations, and going back and forth. And this was a really interesting thing that I personally had never been a part of. This was the first time I'd done this level of concept testing, where we, had, sometimes upwards of 10 to 15 observers. We randomized the order in which we presented the concepts intentionally to not have bias. We had a specific script to follow so that we didn't bias people with how we describe these concepts. Ultimately, to try and get a confident direction of what our customers want and how we want to solve it. So in the end, what we came down to, the conclusion that we came to was basically, these are the requirements that y'all, our customers, were telling us, that we really needed to have project scope add-on management. Now, this is something that I think Eric Reffa mentioned this morning during the LabVIEW roadmap. I'll go into a little bit further here of what we've done to further that, but of course, there's still work to do there. Which, the first thing is, and again, these are kind of my definitions, but this is what we did to try and get on the same page, and how we defined it as project scope add-on management being the ability for a project to define and enforce the add-ons that it requires. And that is inclusive of, a specific version of each add-on that may differ from other projects. So, what does this mean in practice? Realistically, that projects that exist on the same machine can have different versions of the same add-on, or can have conflicting add-ons, and they're isolated from one another. The second big thing that people really needed and wanted was forward compatibility of add-ons. And again, our definition, or my definition of this, is essentially for the add-on to be able to be used in the version of whatever IDE, LabVIEW, or whatever it is, in which it was created, as well as later versions or ensuing versions, and specifically without any action from the really important part. This means that authors don't have to rebuild or re-release their add-ons every time a new version of an IDE comes out. That's particularly important, and something that we saw as an obstacle for getting people to kind of adopt NIPM as their distribution mechanism. Additionally, from the consumer side of this, it's an advantageous because then they also don't have to wait for an author to release something for a new version of an IDE. So they don't have to, they can just go ahead and use it in whenever they need to move up to the next version. So at this point, we had our directive, we knew what we wanted to do, but now we had to figure out how, right? So these are two things that have been around. These requirements have been around. There's a lot of different ways to do it. We needed to look at how we wanted to do it through our software. So we took a step back and looked at NI's ecosystem of software in general. Now we have kind of a unique system where we have system level things like drivers and development environments and high level application software, as well as kind of lower level things like reuse libraries like our standard lib, our analysis VI, things like that are more in the world of reuse libraries. So we needed to figure out a way to be able to support both of these. And ultimately what we came to was there's two types of packages that we need to support. One of them being kind of what is referred to, or at least what we refer to as system packages. These are things that, I have here NI driver, but that's just an example of things that are installed generally once per system, things that generally install things to system directories. So you can imagine putting binaries in the GAC or doing things that affect or manipulate the system-wide, like manipulating registry keys. We wanted to make sure that we were, able to support types of packages like this. Additionally, another type of package that's more along the lines of what is known as application, or sometimes called language packages, which are, again, those kind of reuse libraries, IDE extensions that are installed per project, or per version of a particular IDE. So if you kind of follow this logic and look into it a little bit further, these things really get divided up into two different types of package managers that manage these different types of packages. We have system level package managers. NIPM itself would fall into that category. These are sometimes called OS level package managers. Generally, these are things that install, again, packages that affect things system-wide, like our IDEs and drivers. OPackage, APT, these are other examples of these things on different platforms. And then we have application, again, or language level package managers that tend to install, source code or add-ons to specific projects or shared locations on disk. Things like Python and NPM and even NuGet are examples of these types of add-ons or types of package managers. So we knew that we had to support both of these types of packages, and there's kind of two different schools of thought and different kinds of package managers. So we went to package.community to kind of seek some guidance from them. Package.community, for those who don't know, it's kind of an open online community of package manager maintainers. So the different, tech leads, people from that represent the different package managers. That's a place where they go to talk to further the development and the evolution of package management. So we went there, and specifically they have a Discord channel that our tech lead at the time, Kent Johnson, basically proposed a question of, can anyone think of an example of a package manager that handles both of these things, both system level packages as well as application level use cases? And, kind of I guess you can call it unfortunate, but the answers that we generally got back were along this line of, well, no, can't really think of examples of this, but feasibly it should be possible. It's just these things tend to have such different, requirements, or in this case, she calls them pressures, that they're kind of handled separately. So we are presented with basically a blank page, right? A hybrid package manager doesn't currently exist that we could either leverage conceptually or literally leverage to use for ourselves. So let's take a step back and see, well, what do we have at our disposal, and can we use it? So what we have at our disposal, of course, is NIPM, which, again, keeping in mind, you'll see this slide a couple times. These are the requirements that we're trying to solve, right? So can we solve these requirements with what we have currently, which is NIPM, which, like I mentioned earlier, is a system level package manager. So NIPM, can we solve forward compatibility with NIPM, per this definition, right? Sure. I mean, there's many different ways to solve forward compatibility. The one that most jived, I guess, with NIPM was to have, a project, if a project depended on a particular add-on, let's say my add-on, to install it to a common location, right? Pick your place on disk, a common location, and then teach, the IDE or the project itself to know where to go look and to load and find and load that add-on from the common location. And then, when the next version of that product, using NXG as just an example, that also then knows where to look and find that add-on and load it, right? So pretty straightforward. Other package managers may solve this a different way, but this was the one that we felt most aligned with NIPM and system level package managers in general. All right, so cool. NIPM forward compatibility, we can do that. Now, looking at the other requirement of, can we do project scoped add-ons with NIPM? Now, this is where it gets a little bit trickier, right? Because we have a similar situation, let's say, where we have a project that depends on an add-on, a particular version of an add-on, like my add-on version 1.0.0. We're kind of extending this common location idea where we install that add-on. And again, we teach the project or the IDE to look for that add-on in that common location and load it. And that works fine. Great. The problem comes in where in a different project, whether it be in a new version of the product or in the same version of the product even, if that project needs a different version of that add-on, in which case, in this case, my add-on 2.0.0, which then means we have to install add-on 2.0.0, and because in system level package managers, you can only have one version of a particular package installed at a time, we have to uninstall the 1.0.0 version of my add-on, which then basically breaks this other project. So not really going to work there with NIPM as it stands today, right, as a system level manager, package manager. Well, okay, if we can't do it with just NIPM as it is currently, can we use two package managers, right? This is a pretty common use case, a pretty common solution where, you can have some sort of system level package manager like apt-get install, in this case, Python and pip, which is the application level package manager for Python. And then you use that package manager pip to install the actual application packages like NumPy in this case. Sure, I mean, that's a pretty established paradigm. Let's try to apply that now to NIPM and NI software. So again, we could have NIPM, which would handle kind of the system packages like drivers and IDEs. And we would have, a product specific, in this case NXG, but could be any product, package manager to handle the application level stuff, the add-ons for that particular product. This could work, but this is similar to what we have kind of today, right? In the LabVIEW 20XX world, where we have, multiple package managers like VIPM and GPM in addition to NIPM, which, could kind of works, but there's a lot of drawbacks to this. Each product has its own user experience. There's different formats across the product, which makes it difficult for tools to keep tools in sync. And probably the biggest issue is trying to establish relationships between them, and particularly package relationships, so that they can be kept in sync. And in the end, this is really difficult, or just doesn't really work. So, kind of applying that to this, if we did something with just, the product in NIPM, we have the same issues where trying to maintain packages or relationships between packages would be really difficult, if not impossible. And in that case, now we're back into a world where we have to now rely on users to install prerequisites, right? In this case, if you're installing my add-on, which depends on NI driver, you have to know to install NI driver first, or at least in addition to my add-on. An example of that is today we have a DACMX Python package, and in the documentation it actually tells you that in order to run this, you have to install DACMX, and it points you to where you can download it and install it separately. So, this is possible. This is kind of the world that we live in today, but it's definitely not ideal. So obviously having this as part of a single package manager has a lot of advantages, right? For consistency of experience, for consistency of format, as well as probably the most important thing, being able to have package relationships without having to do any sort of this kind of cross-application communication and synchronization. So what are we going to do? Keeping all that in mind, the fact that we need to be able to handle system packages as well as application level packages, and using just NIPM as it stands today doesn't really work. Having two package managers or multiple package managers can kind of work, but it has its own set of drawbacks. We set out to try and build this hybrid system level, application level package manager, right? Something that hasn't really been done, but we think we're pretty smart. We're going to give it a shot. So let's try and build it. Again, kind of just refreshing our mind here of what we have here. These are the requirements that we need to establish, we need to achieve, project scope add-on management, as well as forward compatibility of add-ons. So let's look at project scope add-ons first, right? So again, we have two different types of packages that we need to be able to account for, to support. System packages, no problem. We do that today. NIPM is set up as a system level package manager. We can do that. So how are we going to support basically these application packages, these packages that we want to be able to install multiple times per machine so they can be installed to the different projects or different IDEs? So for that, we basically turned to and got inspiration from Python, from pip. Specifically, they have a concept called virtual environments, which allows you to create these little silos, these little sandboxes that you can then install different packages, different add-ons, different versions of those add-ons, conflicting versions of those add-ons, within those silos, within those sandboxes. Now, that sounded great. That's something that we thought, we can probably do that. So let's take a look at how is NIPM actually constructed today? And a lot of people may not know this, so I'll pull back a little bit of the curtain here. Today, NIPM has this concept of agents, right? And theoretically, we have this concept of different types of packages, right? We have what we call WinInst packages, which are packages, you can think of it, kind of a high level. They're packages that are based on MSI installers. And then we have file packages, which are kind of your quote unquote regular packages. That the type of packages you would build from the NIPM command line, or one of our products like LabVIEW NXG, or NI package builder. Now, theoretically, these two things are already set up. These two things can handle our system packages, right? So we need to come up with something to handle application packages. So we decided that we would let's create a new agent, and we'll call it the relative file agent, and that'll be we'll talk about that here in just a second. And this new agent would help us support these new application type packages that we want to create. So at a high level, like I mentioned before, we were taking inspiration from from virtual environments in Python and being able to install application packages to different directories and have them live in silos. So at a high level, that's basically what we designed the relative file agent to do. You can specify an installation folder, you can install your add-on. Add-ons of different version or conflicting add-ons could then live on this machine altogether. So how does this apply to project scope, right? Well, when instead of just thinking of generic installation folders, think of different projects, right? So now we can install these new relative file packages directly to sit next to the project, hence relative, and teach our IDEs, teach LabVIEW, LabVIEW NXG, and so forth to know how to find and load these. So that's how we decided that we would solve the project scope add-on requirement. So then going to our next requirement for compatibility, again, this is something that we basically, again, took inspiration from Python, from pip. It has this concept of a global directory, a global area, common area, as well as, again, these virtual environments. So in general, if you don't have a virtual environment created and you install something through pip and installed it to this global site package, so that's something that we, again, took inspiration from, where we now created, as part of the relative file agent, a default installation route. So if you installed one of these new relative file packages and did not specify a particular project or particular directory to install it to, we would install it to this default location that then, every version of a particular IDE, NXG, for example, or LabVIEW, could then find and look for and load. One thing to kind of point out, where kind of veer or detour a little bit from pip and virtual environments, is this pip has this concept or this option for allowing these virtual environment packages to have dependencies on things in the global area. By default, that's not the way that it works, but you can pass a flag to allow that to work. This can be advantageous, that helps you kind of keep from having multiple copies of things, but it can also lead to some issues. Could introduce package relationship issues. So kind of by default, this is kind of the way that it works, where you have each different virtual environment or isolated area contains all the packages that it needs. And so that's really the direction that we went for our interpretation. You can think of it as of that, where we have each project or each installation route is kind of self-contained. There's no cross dependencies to the global or the default installation route. Okay. So before I get into some details, I want to check the chat and see, is there anything in here? Okay. Do you have a timeline on release per project for current gen LabVIEW? I'm going to park that for a second. I'm going to let Greg's going to talk a little bit about kind of how this applies to LabVIEW. I'll park that for just a second. Would this be able to support a toolkit? That depends on NIPM. Stephen, kind of. So I say kind of because technically we know that that's gonna be a requirement as well, right? Most of there's certain category of add-ons that will not have dependencies on system packages like drivers. The ones that are kind of just built on top of basic LabVIEW functionality, things like that come with kind of our standard installation of LabVIEW. But we know that there's going to be a decent amount, like for instrument drivers as an example, that will need to depend on drivers, and that is something that we are going to have to solve. It's not something that I'll like I said, if I have time, I can do a quick demo. It's not something that we have enabled right now. In fact, we have it explicitly disabled to be able to allow relative file packages to depend on system packages. Not because we don't think that is valuable, because we do. It's mostly we don't have time to solve it right now, but we want to get this out to you. We want to get this out so that people can start using it and trying to see if it works for them. And in doing so, we have intentionally restricted some things so that we could get it out faster so you can start using it. And that's one of those things. But it is something that we know that we will have to solve at some point. Do you want to support Linux at some point? That's a good question. In terms of having NIPM on Linux, I think that's going to depend on whether we need some of this. You can think of it as NIPM. Linux obviously has its own slew of package managers already. We use some of them to distribute our software on Linux as it is. If and when we need to have this sort of NI-specific functionality, you could think of it as some of these relative file packages being one of those. It's possible. I'm not going to make any promises, but that is something that we are talking about and looking into. Okay, I'm going to go back and keep going. So I just have a few more slides, and I'll turn it over to Greg. But I wanted to get into a little bit of some of the details, right? I'm sure you guys want to know. That was pretty high level of just high level design of how we want things to work. So let's get a little bit more detailed. At a basic level, the structure of a relative file package is very, very similar to a regular file package, right? We have a control file, we have a data folder with a payload. The big difference is underneath the data folder, you can create a directory structure, but you're not specifying specific places on disk to install things like the desktop or documents or package or program files or anything like that, because everything gets installed relative to where you tell it to install that package, right? So yes, underneath data, if you wanted to have a directory structure, like you want to put let's say you're having documentation along with your call. But the big difference is everything is installed relative to where you tell it to install to, or relative to the default location if you don't tell it to install to any particular place. And there's not specific folders or paths on disk that you install to. From a control file attribution perspective, it's basically the same. The big difference is we have this plugin attribute that is NIPM or NIPKG specific. In general, our control file, our packages are based on, I say based on, inspired by. We don't claim compatibility with, but inspired by Debian. We added this plugin attribute that basically, at a high level, it says what agent to use, right? So in this case, relative file, that's the new agent that we just created. There's other options like WinInst and file that tell you to use a WinInst or the file agent. So that's really the big difference from a control file perspective. From a building and installing perspective, again, same sort of thing. You have, I don't have it here on the slide, but you call the same function you call pack from the command line, or or our products are starting to utilize this. But essentially, you create your directory structure, and using the CLI, you call pack just like you would do for any type of package, and it would create a packet for you. From an installation perspective, again, we tried to make this as straightforward as we can. The big change is in our install command, as well as our remove, upgrade, repair, list, kind of all the different CLI commands now have a new attribute, or sorry, a new parameter that you can pass called install root, which when you're installing or operating on, in this case, installing a relative file package, if you pass an install root, that tells the agent to install it to that particular place or to look in that particular place. So this is where you can tell it to install to a particular project or a particular folder. Otherwise, like you see here in the first one where we're installing my add-on A 1.0.0 and my add-on B, those two will install to the default install root, and the next one will install to project 1, and the next one will install to project 2. And this is how you can have, again, multiple versions of the same add-on, like my add-on A 1.0.0 and 1.0.1, as well as conflicting add-ons like add-on C, which conflicts with add-on A, all existing on the same machine because they're in isolated locations. Our GUI, I guess it's worth mentioning right now, the NIPM GUI does not currently support you specifying where to, it doesn't give you like the option to like browse to a particular place. So if you want to install a relative file package from the GUI by double clicking on it or including it in a package installer or putting it in a feed and finding it in the feed and installing it from the GUI that way, it will always install it to the default location. If you want to install it to a particular directory, you have to do that through the CLI currently. Speaking of directories, so this top one here, this is where we've chosen currently to have our global, our default directory, whatever you want to call it, is in a folder underneath the package manager directory and program files called installed. So this is where, again, this is our default or our global location. And you can see that it has its own database here. Additionally, anytime you install to a non-default location, like project 2 here at the bottom, we create a new database there that keeps track of all the things that are in that directory and siblings to that database. Within each one of these, like I said, it's all relative to that particular route that you passed in. So we have any sort of subfolders you were creating, as well as any payload that you chose to put into your package. Okay. So at a high level, this is the approach that we're taking, right? Like I said, we're trying to create this hybrid package manager that can support both system level things using our WinInstant file agents, as well as application level packages using this new relative file agent that we created, which again will install things either to a default location or a specific installation directory like a project, and allow you to have multiple versions of the same add-on or conflicting versions of add-ons on the machine at the same time. All right. So, well, before I pass it on to Greg, you're probably wondering how you get a hold of this. So this relative file agent will be enabled. Or the intention is, I don't want to make any promises, even though it's coming up pretty quick. The upcoming version of NIPM, which we'll release here in the next few weeks. If you are interested in learning more about this or trying to use it, I would be definitely interested in following up with you. So feel free to shoot me an email. I should have put my email on here, but if you don't know it, let me know. Like I said, it's going to be enabled by default. So definitely give it a shot and see. Let me know what kind of feedback you have. All right, so I'm going to hand it off. Well, I'll stop and see if there's any questions, and then Craig, you can go ahead and take over from there. It says, will feeds be able to contain all kinds of packages? Eric, yes. Oh, Alan already answered you. Yes, it will. So in the same feed, you can have file packages, relative file packages, WinInst packages, and they can all have dependencies on each. Well, the file and the WinInst can have dependencies on each other, and the relatives can have dependencies on each other, but not back and forth like I mentioned earlier. I'm concerned about current Gen's ability to have VIs on disk when you're happy when they're being loaded and linked for multiple projects. Has this been addressed? I'll let Greg address that if he knows the answer. So, Greg, go ahead and let me know when you want me to advance the slide.
Go ahead then. Okay, so Aaron has been covering this topic mostly from the technology, package manager technology standpoint. I'm going to take a slightly different tack on it and talk about LabVIEW plugins, add-ons, all the different things that we've collected over the years to allow the environment to be extended. So most of you probably know what I'm talking about, at least in part, but files can be installed in instr.lib, and that is typically where instrument drivers would be installed. User.lib, even VI-lib, things from NI and from other third parties will get installed there, and they will extend the library capabilities of what is available in the palettes. Similarly, they can install manuals, help information, examples, templates, and can do menu customization if they want to present their stuff in a specific way. And of course, getting more advanced, there's ways to extend the environment itself, adding things to the menus, adding things to the projects. So to date, these only work on a specific version of LabVIEW. So if you were talking about LabVIEW 2020, then these get installed into the NI LabVIEW space 2020. That's all we've ever done. That's all we've ever supported. And one of the big drawbacks on that is that when you install LabVIEW 2021 or 2022, it cannot use any of those add-ons. They must be reinstalled. This is true of add-ons. It's also true of even things like drivers. And this is the primary problem. This is the initial problem that we want to address. We will eventually also get around to supporting what Aaron was talking about with per project libraries. I think a lot of the mechanisms will be the same. But we're initially going to talk about forward compatibility or version independent add-ons. Advance. Click. There we go. So we hope in many ways that not that much will change. If you provide an add-on to LabVIEW, whether it's built in-house or whether you have it as part of some package manager or just an FTP site or whatever, no matter what technology you're using to install, we want to continue supporting the traditional installation location. So if you are installing something that you are only going to test and support in one version of LabVIEW, then the existing locations are the recommended place to put them. But what we want to do is we want to allow for numerous isolated add-ons to be installed in this more global location or in a number of locations, in the future even down into project-specific locations. The LabVIEW development environment will then read those and will merge them inside the environment. So they will not be merged by the installer, they will be merged by the development environment. But what we think we want to do, and this is a point of feedback, is what we think we want to do is to go ahead and maintain many of the definitions. So any of those locations can extend intro.lib, user.lib, VI.lib, menus, projects, and so on, and help and manuals and such. But the big point is that they will now be isolated from each other and you won't have file conflicts. And installation and uninstallation and upgrades won't impact each other nearly as often. Go ahead and advance. So that is the approach that we're going to take. And of course, as we do this, we will make additional recommendations. Currently, there are still many add-ons that ship with the object code and the source code in the same file. So we would like to, we will start encouraging, and then I will start following these rules. We will start shipping more and more of the VIs as source only. The convention is that you would compatible version. So perhaps if they your VIs are expected to work all the way back to 2015, that's when where you would save the VIs, and that's how you would ship them. You would install them in a global location, expecting any version of LabVIEW going forward from 2015 to be able to load them. If you are shipping binaries that are made out of VIs, you might want to consider using the backwards compatible runtime engine, the BCRTE. Options for things like applications and DLLs and PPLs and such. Additionally, we need to start following these rules ourselves, but we want to start right protecting the folders where this content is going. The operating systems are more and more encouraging or requiring this. And so we want to just remind anyone who's doing add-ons, we'll probably encourage them to put configuration files and caches and documents and stuff like that in a more appropriate location, and that these were installed and they're not to be modified except by further installations. I think that's all I had on that slide. So time frame and scope, and then I'll look at some of the questions. So initially, NI is looking to do this imminently with drivers. So DAC, Visa, the drivers plug into LabVIEW in different ways, and some of them will be easier, and we'll perhaps go first. But we want to do this so that our drivers do not need to be reinstalled when you upgrade a version of LabVIEW, and these will not be as coupled as they historically have been. We want to publish these mechanisms so that anyone else who has an add-in or a plugin can also take advantage of them. So we'll be hopefully upgrading documentation and fixing issues, long-standing issues with LabVIEW's ability to load things from multiple locations. So let me look back through the comments and the questions. And feel free to add your at this point if you haven't already. So there's a question here about whether we are saying that each project can identify its own VI lib. Specifically, what we're saying right now is that a particular LabVIEW can have its VI lib segregated out into numerous locations that will all be merged together. We already do this to a degree with the targets folder, so we can have target customization, but we will be able to have drivers and add-ons installed independently, but take part in a particular LabVIEW's VI lib universe. It is feasible as we add per project libraries that we do allow you to specify where, get more visibility and modify where your libraries get loaded from, however. To this point, there is a pretty standard specification for where libraries get loaded from, but it's not that modifiable. Only the search path is modifiable. So Chris, we're not exactly saying that yet, but I think it's in the cards. Reading through some others. Okay, there's a question about how we will know which location is used to load these various files. That's a good question, Gabrielle. I think that we will start to expose more of these load reports so that you can tell exactly where things are loaded from. Currently, these are available for most of the build tools. You can turn on a log file and see exactly which files were built into an executable. But we don't generally have that for the load environment. And I do think that maintaining a cache of those makes sense, especially as things get a little more complicated. There's a question about being able to mass compile VIs when they install. We are actually looking at what we are more generally calling the warm-up tool, because mass compile is really very old and dated technology. It assumes that the object code is stored in the VI, which is, it still happens, but we would like to discourage that, especially if we start to look to more independent files. But the object caches could be warmed up with another tool that is either fired off by the installer or in the environment or by a project setting. There's several others coming in. I'm getting a little lost. So there's a question about Veristand. I do not know anything. We have not had conversations with Veristand yet. I do think that if NI drivers are starting to change where they install, that all NI tools will have more of this capability. Yes.
Yeah, and just to mention, so the whole relative file stuff that I was just talking about is basically product agnostic, right? It was intentionally developed to not be specific to any particular IDE or application, so that it could be hopefully leveraged by many of our products, however they see best for that product.
There was a question about this working in older versions of LabVIEW from Eric. What I'm saying is that newer versions of LabVIEW will allow for packages to be installed in a version independent way. Older versions of LabVIEW won't be changing. They will still need things installed inside of their development folder. So they'll need to be in the NI LabVIEW 2016 folder. That's the only place it knows to look for VI add-ons and other plugins. There's a question about being able to select which version of a driver is used by LabVIEW. This is not something that the operating systems and Lab generally support, and LabVIEW is not really set up to override what the operating systems are doing in general. But there are some technologies that are being used by some NI, more advanced NI products, and they may be migrating to be used elsewhere. I don't think I want to go into any more details on that, but there are products currently shipping by NI that do allow you to quickly switch out which versions of drivers you're using, because I do think there's some benefit in that. Okay, there's a question about the warm-up tool publicly available. No, it is not. That is still something. There may be some early versions put up for testing, beta testing of this before it is. Definitely want to do this with feedback. We do not have all the applications in-house or all of the add-ons, but at this moment, this is still research and mock-up. We do not have anything available. Okay. Do you see anything that you want to address, Aaron?
No, I don't think so. Not off the top of my head. Obviously, we can take this into the breakout room after, and if people are interested and want to ask more questions, that would be good.